In this video, we're going to talk about vectors. So here is a vector that has its starting point at -1, and its ending point at 2, 4. To find the component form of the vector, if you know the points, we think of that as x sub 2 minus x sub 1 and y sub 2 minus y sub 1. So we want to make sure that your ending point is x sub 2, so 2, 4 is x sub 2, y sub 2, and -1 is x sub 1, y sub 1. So if we stick it into the formula, so it's just the difference of the x's and y's, it will be 2 minus a -1 for our x, and 4 minus a -1 for our y. And that's going to be 2 plus 1 and 4 plus 1. So it's 3, 5 for our component form. Now they've also asked for the magnitude. Now the magnitude of the vector technically is just this length. When you have it in component form, it's really easy to find the magnitude. The magnitude of a vector, they usually represent with either 2 bars or 1, is the square root of the x component squared plus the y component squared. And it all is based upon the Pythagorean theorem. So it's just 3 squared plus 5 squared. And that sum is we're going to square root. So that's 9 plus 25, or the square root of 34. Now if that could be reduced down, we would reduce it down. So that is 41. So let's take a look at number 42. We want a vector v with the same magnitude as 75, a magnitude of 75, and the same direction as u, which is the vector -724. So first let's find its direction. The direction is represented by theta, and it is the inverse tangent of the y component divided by the x component. So in this case, it's the inverse tangent of 24 over -7. Which is 106 degrees. Now take a look for just a minute. Our u vector is 7 to the left and 24 up. So it makes sense that our angle should be somewhere between 90 and 180. So it is 106. So we found the direction. Now we want our vector to have the same direction. So the vector form that shows the magnitude and the direction, you just want to write that as the magnitude in front of the cosine of theta and then the sine of theta. Okay? So our magnitude, so vector v, should be written as 75 times the cosine of 106 sine of 106. And that's basically how you could rewrite it, so that it has the same direction as u, but this one will have length 75. So there you go for number 42. Now for problem 43, you've been given v's magnitude and direction, and we want to write it in component form, exact values. So let's start with v. Now we know that v's magnitude is 2 and its direction is 45 degrees. So if we want it in component form, it would just be r cosine theta is x, r sine theta is y. So we're just going to write that as 2 cosine of 45, 2 sine of 45. Now, we want to use our knowledge of the unit circle to go further than that. So the cosine of 45, exact value, not on a calculator, but exact value, is square root of 2 over 2. Same thing with the sine. And then the 2's are going to cancel, so that's just radical 2, radical 2. So that's part A. Let's do the same thing for B. For B, using this same formula right here. So our R for part B is 9/8. Our theta is 150 degrees. So it would be 9/8 times the cosine of 150, 9/8 times the sine of 150. Now, the cosine and the sine of 150 are things that we would use from the unit circle. Now, if you think about it, the point on the unit circle for the cosine is negative square root of 3 over 2 1/2. So that's 9/8 times negative square root of 3 over 2. And then 9/8 times positive 1/2. You want to distribute, and our final answer would be negative 9 square root of 3 over 18 and 9 over 18. So that's how you do 43. Let's take a look at 44. So for 44, we have a force V of 160 newtons and a force U of 305 newtons acting on a hook. And they've showed us where the U force and the V force are. The angle between the two forces is 45 degrees. Find the direction and magnitude of the resultant of these forces. So we're going to put them into component form. Let's start with our V. Our V's magnitude is 160. And then we've got the cosine of 45 and the sine of 45. So that's 160 times square root of 2 over 2. 160 times square root of 2 over 2, which is 80 radical 2. 80 radical 2. Okay? And those are newtons. Now let's deal with vector U. Its force is 305. Its components of its unit vector is the cosine of 0 degrees, the sine of 0 degrees, which is 305 times the vector 1, 0, which is 305, 0. Now, to find the resultant of two forces, if they are in component form, we can just add the two vectors together. Okay? So, U plus V, the forces acting together, would be 80 radical 2 plus 305, 80 radical 2 plus 0. Okay? Now, that's the resultant vector, but look what they've asked us for, the direction and the magnitude of that vector. Okay? Well, the magnitude of that vector, you're just going to square root 80 radical 2 plus 305 squared and plus 80 radical 2 squared. And I am going to, put that into a calculator, and I'm going to square root it. And I'm going to get 433.17 newtons. Okay, so that's the resultant force. If we were to draw the resultant force, we could do the parallelogram method. And it would be right here, approximately. Okay, so our resultant force would be right there. Okay. Now, so that's the amount, 433.17 newtons. Now, let's go ahead and let's do the angle measure. Now, the angle measure, we're just going to take the inverse tangent of the y component divided by the x component. So that is the inverse tangent of that y component, 80 radical 2, over my x component, and I would put that in parentheses. Let me make that a little better here. And you get 15.14 degrees. And if you look, that makes sense. It's your angle's right there. Okay, so that's 44. So here's 45. We are going to represent the vectors, the complex numbers, graphically using vectors. We're going to write the trigonometric form of the number, and we're assuming that we're somewhere the first flip around our unit circle. Okay, so let's start with A. So remember, our x-axis is our real axis, our y-axis is our imaginary axis. So 4 plus 4i is in component form 4, 4. So we're going to go 4 to the right and 4 up. And then our vector would be represented by that yellow line. Now, let's talk about the trig form of that. The r is going to be the square root of our x squared plus our y squared, or our a and b if you're talking about complex form. 16 plus 16 is 32, so that is the square root of 32, which, because that is 2 times 16, that's going to be 4 radical 2. Now, trigonometric form, we need our theta. Well, our theta is on the unit circle. That is the inverse tangent of 4 over 4, which is 45 degrees. Now, you'll notice that they use radians, so let's make that pi over 4. And so our final thing that we need to write for part A is that 4 plus 4i is the same as 4 radical 2 times the cosine of pi over 4 plus I times the sine of pi over 4. And there you go. That's part A. Now let's try part B. So in part B, we're at the point 3 negative radical 3i. So we're going to go 3 to the right and negative radical 3 down. We're going to draw our vector. Okay, so that would be the point there. The radius Well, in component form, we could think of it like that. Our radius is the square root of the a squared plus the b squared, or the x and y component. So that's going to be 9 plus 3, or the square root of 12, which is 2 radical 3. Our theta is going to be the inverse tangent of our imaginary component, that's our y component, over our x component. Now that is in our fourth quadrant. That happens at the pi over 6's. So that would be 11 pi over 6. Now in form that we want, so we end up with, you show your magnitude, 2 radical 3, in front of the cosine of 11 pi over 6 plus I times the sine of 11 pi over 6. There you go. Now let's look at C. Now C is a nice one. It's just negative 2i, so you can think of it as 0 minus 2i, or components 0, negative 2. So when you graph it, it's just basically down here. At that point right there. Now, we know things about that from what we learned about the unit circle. So its magnitude or radius would be 2, and its angle measure is 3 pi over 2. So then we can immediately put it in the form we want. So it's going to be 2 times the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2. And then finally, let's do D. Negative 7 plus 6i. So your components are negative 7, 6. So it'd be here. Not the greatest graphical representation, but I think you get the idea by now. So our radius is the square root of negative 7 squared plus 6 squared, which is the square root of 85, and then that can't be reduced any further. The theta this time is the inverse tangent of negative 6 over 7. And that is not something we know from the unit circle, so you would have to enter that into a calculator, and that's 140 degrees. So in polar representation of that complex number, it would be square root of 85 times the cosine of 140 plus I times the sine of 140. So there's the trig form of your complex number. There you go. Now, let's look at these polar numbers. So our r is 4, our theta is 5 pi over 4. Now, a graphical representation of that is if you think of this again as 0, and this is pi over 2, and so on. This is a radius of 1. Excuse my circles, 2, 3, 4. So we have a radius of 4 at 5 pi over 4. So we go to 5 pi over 4, which is in this quadrant right here, and we go out to a radius of 4. So it's that point right there. Let's look at, we'll do some other things to these in a minute. Let's try B. Okay, so again, here's 0, here's pi over 2. We have a radius of 1, 2, 3. Now let's look what negative 3 means. So 2 pi over 3 is about here. Okay? Now, what it says is we want to go negative 3 on 2 pi over 3. So technically, it would bring us down the opposite directions, because the negative gives us the opposite direction, just like a vector does. And so we go the opposite direction 3. So that right there is also could be represented as positive 3 on the (5 pi over 3 location. Okay. Now, as far as, let's just talk about how we would write that in complex form, because that's something we have done in the past, and you may not have seen a representation of a polar like that. For 5 pi over 4, that would be 4 times the cosine of 5 pi over 4 plus I times the sine of 5 pi over 4. So if we wanted the complex number that went along with that polar, it would be 4 negative square root of 2 over 2 plus I times positive square root of 2 over 2. And then if we distribute the 4 in, we get negative 2 radical 2 plus 2 radical 2I. So that is the complex number that matches that polar. And then if we do that again, that would be negative 3 times the cosine of 2 pi over 3 plus the sine of 2 pi over 3I. Let's put the I in front here. And then that would be negative 3 times negative radical 3 over 2 plus 1/2 I. And when you distribute, you get a final complex number of 3 radical 3, 2 minus 3 over 2I. Do you see how it puts us in that fourth quadrant? Because the x is positive, or the real component is positive, and the y component, or the imaginary component, is negative. So it would put us in that same quadrant. So there's 46 for you. So we're going to rewrite this in rectangular component form. So our r is negative 3. Our theta is 5 pi over 6. Remember, x is our cosine theta. Y is our sine theta. So the component form, the x is negative 3 times the cosine of 5 pi over 6. The y is negative 3 times the sine of 5 pi over 6. If we think back to our unit circle, the cosine of 5 pi over 6 is negative radical 3 over 2. The sine of 5 pi over 6 is 1/2. Then we just need to make that look a little better. So that's 3 radical 3 over 2 and negative 3/2. So our xy form is 3 radical 3 over 2 minus 3 over 2. So that is our polar coordinate, our r theta, converted to rectangular coordinates. In our last problem here, we're going to take the rectangular coordinate and go backwards and find the polar. Now, they have told us but we just want the r to be a positive value so we don't have to worry about flipping it backwards or using negatives, and that our angle measure is somewhere between 0 and 2 pi. So that just narrows things down for us. So think about for a minute where that lands you so that you can kind of get a sense that you are correct. If I go 3 to the left and 3 down, I am in the third quadrant. So just keep that in mind. Now, first let's find our radius. Our radius is the square root of the x component squared plus the y component squared. So that's the square root of 9 plus 9, or the square root of 18, which is 3 radical 2. Now, theta is the inverse tangent of y over x. So that's the inverse tangent of negative 3 over negative 3, or the inverse tangent of 1. Now, that gives you a reference. Like if you were to throw that into a calculator, if you wouldn't think of it on your unit circle, but if you were to put it into a calculator, that would give you 45 degrees. But it is the reference angle of 45 in the third quadrant. So technically, that's 225 degrees, which is 5 pi over 4. Okay? So our polar representation, our r theta, is equal to 3 radical 2 and 5 pi over 4. And there you go. Those are your vector polar complex problems.